Welcome, welcome, welcome. Welcome everyone to this session today. I know we were looking like zombies before, but now we have real pictures. Today we're here with Nuro, and we're going to be talking about how Nuro is using certificate authority service to secure communication between the autonomous vehicles and the cloud and other software update service. We have here with us today, we have Jeff, who's the security engineer at Nuro, and we have Michael, who is the software engineer at Nuro. I am the product manager for certificate authority service. And we also have JP, who's in the audience. JP's been helping a lot with the whole architecture and connecting Nuro with various Google resources and has done a lot of work for us. So before we get into the fun stuff, which is how Nuro is doing everything, I'm going to give a very basic introduction to certificate authority service for those people who are less familiar with the service. Certificate authority service allows customers to create cloud-based certificate authorities to issue private certificates. These certificates can be used in various scenarios. We support a lot of different algorithms. We in compliance with various standards. The keys are stored in HSMs, all the typical features of certificate authority. I would like to highlight three main things about CAS, which makes it very differentiated from other offerings out there. First of all, CAS is very simple to use. It is basic GCP APIs integrated with Terraform, KCC. So any developer could basically come and run a few commands and get up and running. This is much better than traditional certificate authorities on-prem, where there's actually a whole team of PKI experts who have to manage them and you have to work with them. And in cloud deployments, that's not very useful, right? Because you're going to have to spend out a lot of time interfacing with that team. The second thing about CAS is that it's deeply integrated with Google services. Services like Anthos Service Mesh, internal load balancers, external load balancers, secure web proxy, GKE. CAS has direct integration with those systems. So whenever you need certificates, Google will auto-manage the certificate, rotate the certificate, and so you don't have to worry about it. So these integrations are really useful. Finally, CAS is probably one of the most scalable and highly available CAs out there in the industry, because Google internally also takes dependency on certificate authority service to operate. So that's why it's really important for us to operate at high scale. We're able to generate hundreds of certificates within a few seconds. This is something that is generally unmatched in the industry. Now, once these certificates are deployed, there's three main use cases. The first one is around microservices. So you have containers, microservices. You can use these certificates to identify these services and enable service-to-service communication, whether that's TLS, MTLS. We also allow enterprise IT scenarios. So if you have like employees who have laptop, you can deploy these certificates into the laptop and securely connect the laptop with your Wi-Fi routers, as well as, when they sign in, the certificates can act as a second factor for certificate-based authentication. Finally, which is the scenario we're talking about today, is IoT devices. So a lot of IoT manufacturers need an identifier and need an identity on each of the IoT device to identify them and enable them to access cloud resources and set up various microservices, set up communication. And that's what we're talking about today. And so with that, I'm going to pass over to Jeffrey, who's going to talk more about what Nuro is doing in this space.
Cool. Yeah. Thanks, Sean. So, hey, everyone. I'm Jeffrey. I'm a security engineer at Nuro, and want to start off talking a little bit about who we are and what we do. So Nuro is an autonomous delivery vehicles company. So we focus specifically on local goods delivery. And so you can see in this image what one of our vehicles, our bots, would look like when it's driving around in the neighborhood. And in terms of our tech stack, we use a lot of the cloud. We use a lot of GCP. So when we approach the problem of how do we securely provision identity on our vehicles, certificate authority service, as Sean mentioned, really stood out as a use case. So let's dive right into it. So as a security engineer, a lot of our focus on how we can secure our cloud infrastructure as well as internal infrastructure. And we've set aside a few goals that we want to accomplish in this project. So starting off with having a unique vehicle identity. And so we wanted something that could be cryptographically proven, such as a certificate, which we could use to authenticate with our services, both Google Cloud-wise and also for our internal services. we also wanted a way to be able to get this certificate onto our vehicles for provisioning, and also when we want to do decommissioning, revoke this certificate. So if you think about the vehicle lifecycle or IoT lifecycle, in the beginning, you're doing the provisioning on manufacturing, and then at end of life, or perhaps during a security incident, you want to revoke this permission. I think it's also important to mention rotation and rotating those credentials, which is a little bit of a combination of decommissioning and provisioning. Then lastly, what do we want to do with this identity? We're going to utilize it to support our cloud and service integration. So we'll be talking about what sort of GCP resources we use with service accounts, and then also diving a little more into how we utilize it for our software updaters to make sure we're connecting with builds that we know are trustworthy, and we're also pushing builds to vehicles that are trustworthy. Cool. So diving right into the provisioning architecture, I wanted to highlight the various components that are involved at a high level. And so on the left, you can see we have our vehicle. So this is where our identity is going to start and where it's going to end. And you can see that there's a TPM there. So what that stands for is a trusted platform module. And you can think of it as a computer chip or a security chip in your system, and that will help provide secure cryptographic operations. So, for example, if you want to generate private and public key pair, that will help make it very difficult for the attacker to retrieve that private key as opposed to taking it from a disk. Next, we have our vehicle service. So this you can think of as our coordinator. So this will communicate with our vehicle as well as the other components involved, so CAS and service account. And generally, you can utilize this to also help persist some of that data related to your vehicle. So you might want to use like a database to keep track of any metadata related to your vehicle as well. And then certificate authority service, sort of the bread and butter of our public key infrastructure. As Sean mentioned, it's very useful in terms of alleviating and abstracting a lot of the workflow that we have to do to manage it and provision certificates. And so we'll be looking at how we design the hierarchy for that. Then lastly, service accounts to establish per vehicle or per IoT device identity that we can use to communicate with Google services. So diving into a little more about the flow of the actual structure, on the left, we again have our vehicle, and we can utilize it to generate certificate signing requests. So this will contain information that's relevant to your vehicle, which can utilize with your public and private key pair to include the signature and the public key that will then be validated by the CA. And we've also had some sort of bootstrap credential, which can help authenticate to your vehicle service. Generally, very little privilege, just to make sure that there's some form of authentication with your vehicle service. And then these two pieces of information is passed to your vehicle service, which can then say, hey, given these vehicle identities, is this one that we expect to be claimed? So having some defense in depth. And then from there, the vehicle service can decide, okay, should we proceed with the flow? If so, it'll pass the certificate signing request to our certificate authority service here. And so you can see there's a hierarchy in terms of how we want to structure the certificate authorities. So we'll have our root CA followed by subordinate certificate authorities. And the reason why we're doing this is to provide a hierarchy that has more levels than one, to ensure that for security reasons, if you need to rotate that certificate, you can more segregate the certificates underneath the specific subordinate CA rather than just the root. And depending on your use case, you might even want to have a per region subordinate CA, but generally you want a level that's more than one here. And so your vehicle's subordinate CA will then sign that certificate signing request and return back the certificate. And for our service account, there's generally two ways, to retrieve the service account key. We can either download a service account key from the service account and then pass that as a private key or service account key back to the vehicle. Or you can upload the public portion of that key in the form of a certificate to create a service account key. And the benefit of doing this is that we can keep the private key present on the vehicle or the TPM in this case. We don't have to pass it around to our vehicle service and onwards. And so that's why you can see there's only one arrow going to upload that certificate to create the service account key, and no arrows coming back. And then lastly, our vehicle service is going to return back our certificate to the vehicle. And I think it's a good place to mention, so the database earlier, to have some sort of metadata stored. So for example, the resource path to the certificate. So later on, you know where to revoke that certificate during end of life. Cool. So diving a little more into the use case with Google Cloud. For us, we use a couple of Google services that I want to mention today. So firstly, with PubSub. So we can publish for telemetry reasons, data that can help us decide, whether or not a vehicle is healthy, improve our observability there. And then similarly for logging, for observability and debugging purposes, is super helpful. And one of the ways we decide to approach, managing the IAM permissions to provision and communicate with these Google Key services is by using groups. And so instead of having to provide permissionings for each service account directly, which can be pretty inefficient, we can utilize groups to manage for a certain group of vehicles. They will have these permissions. And so that'll give you more flexibility in terms of, hey, these fundamental permissions are going to be present for all our vehicles. Maybe you want to have nested groups to say, these vehicles in these regions have these IAM bindings as well. And so that's why we decided to go with this structure. Cool. So now I'll hand it off to Michael to discuss the software updater use case.
Cool. Yeah. Thanks, Jeffrey. So I'm Michael. Jeffrey was working on the core infrastructure for provisioning the certificate and getting that onto the vehicle. I had no part in that. I came into the picture when we had to integrate this new identity system into our vehicle over the network software updater. And that's where I put a lot of my time. So for building such a system, security is super important. You would probably even say that it's a prerequisite for it to exist. Unfortunately, depending on how you do the credentials and other things like that, it can impose a lot of operational overhead on the general flow and use of the vehicle. And Nuro had a legacy credential system that unfortunately imposed a lot of these operational concerns, even though it was fine from a security perspective. So here's how it worked before. So we would generate, the updater on the vehicle would generate a key pair on the vehicle. And during the first boot, first connection to the updater backend, it would do a key exchange, send its public key off to the backend. And in order for that public key to be trusted, a human admin, person with human admin privileges had to go and trust it, examine the credentials, make sure that it looked okay. And this imposes a lot of problems, because now, like, if you ever need to provision a vehicle for the first time, or if you have anything that causes the key pair to be destroyed, lost, wiped, and this can happen for a lot of different reasons. Like if you have to do hardware swaps, if you have to wipe the disk, software corruption, other hardware problems, any of these problems happen, then you have to retrust. And this became sort of difficult from an operator perspective, because then like the updates would stall until you go into the backend and actually fix it. So this caused a lot of problems. It also makes it harder to rotate the credentials. And the problem here is really about the time dependence. Like you generate the key pair and then someone has to go do it then and there, versus with the certificate-based system, you can, since you're trusting the cert, you can generate the cert a bit earlier and send that without having to re-trust on the spot. So with the new certificate-based system, what we would do is we had this MTLS proxy, and for each request, we would attach the cert, and that would be validated by the MTLS proxy. And then the proxy, if it passed the check, would authenticate with the updater backend, attach the correct credentials to it, each request, and then forward it along. So with this system, it made it a lot easier from a operational perspective, because you can rotate certs a lot easier. If you run into issues, you have to wipe the disk. You can re-provision certs a lot faster without as much without escalating to someone with admin privileges. Also, this flow is a lot easier it's a lot simpler from an on-device flow perspective, because, what we had before was we had a bunch of each system that needed to talk to a cloud service needed to do their own auth method. So we had like the updater backend generating their key pair. Some would generate certs, some would generate something else. Some would use like a service account key, and all of these imposed complexity onto the system. With the new software vehicle certificate, this is really unifying all of that into a single system and really simplifies our on-device flow. So overall, this is making our software a lot better. So thanks, Jeffrey. Back to you.
All right. Thanks, Michael. So yeah, I want to finish off by talking about the decommissioning portion. So how you want to revoke your certificate. And Certificate Authority Service supports this through certificate revocation lists. And it's pretty nice because when you decide to revoke a certificate, it'll provide a, I believe, 15-minute guarantee that a new certificate revocation list will be pushed that will contain the revoked certificate. And so you can see that on the right side of the diagram here. From the revoked vehicle certificate, you talk with your relevant certificate authority to get your new certificate revocation list. And I think one important thing to mention is that for your service account, which utilize the certificate for the service account key, just by revoking the certificate, it doesn't necessarily prevent your service account key from authenticating with the service account. So this was an area that I think is important to ensure that the authentication is properly revoked. You'll need to explicitly disable that service account key. And that's why in this diagram, you can see it's a separate step on the left where we'll need to do that explicit disabling. And generally, with your authorizing services, you'll want to double check that the certificate revelation list, the newest one, is getting propagated. And if that doesn't work, then maybe you can look at a different use case where it's similar to service accounts, where you'll need to explicitly disable authentication. And overall, this is to show that after doing the provisioning, to ensure that during your decommissioning process, that for that identity, all the relevant permissions are properly descoped. So yeah, I think with that that the presentation. Yeah, thank you for listening. And if you guys have any questions, feel free to ask as well.
Yeah. And yeah, if if there's follow-up questions, there's a QR code here as well. You can scan and ask more questions, if there's no time here as well. But yeah, feel free to ask any questions.